Okay, so we talked about this case just earlier. So we're talking about the elimination of the epsilon rules, where you have a rule of the form a arrow epsilon. A is a variable, so you eliminate that rule from your set, a arrow epsilon, and then you go looking in the other rules on the right hand side of their rules and to see if you can find the symbol, the variable a. And if you can, for each time the a appears in a rule, just eliminate it, and the resulting rule, put that into your real set. That would be a new rule. For example, here you could eliminate that one, so you'd have UVAW, like here. That would be a new rule, add to your set. Or you could leave it in and eliminate this one, so you'd have then UAVW, which is this one, and you add that rule to your rule set. Or you can eliminate both, so you just get a UVW. So this third rule you could add to your rule set. Okay. Now, if you have something like this, that's it. There's just a single A on the right hand side. Then all you do is you add this to you eliminate that, and you replace it with this on the right hand side, unless you've already removed that earlier. Again, the same old question keeps arising: the justification for all these steps. Why? Same answer. All right. So you just keep doing that until all your epsilon rules are removed. Okay. But don't involve the start state S. That's the start state of your old grammar G. Okay. Now, third step in detail. The third step is about the unit rules. You remember what they were? They had a single variable on the left-hand side, as all rules do in context-free grammars, and a single variable on the right-hand side. So of the form A arrow B, let's say. Okay. So you remove those rules. They're just called unit rules of that form. So if you have a unit rule of this form here, just remove it, and then go looking in the right-hand side of the other rules to see if you can see a B of the form. So it'll be B arrow U. Now this U here, that's just a general string. It could typically be a mix of terminals and variables. Okay, so this is just another string. Now we've eliminated this, but to repair the damage, so to speak, can you see that what is this saying? It's saying substitute A for B, and this is saying substitute B for U. So that's effectively the same as saying substitute A for U, right? Okay. So add a new rule here, just A arrow U. You substitute, A is substituted for U. You rewrite A by U. You put a U where you had an A. So kill this one, go looking for a B, whatever's here, in the right hand side of your rules, and for each time you find that B, if you have a rule like this, where the B's on the left hand side, then add, you've eliminated this one, but add this rule. So A arrow U, which sort of makes sense. Okay, unless this rule was eliminated earlier. So don't go adding rules that you eliminated previously. The whole point of removing them is to get rid of those rules that are incompatible with normal form. So don't go adding things that you've previously eliminated. It sort of destroys the point. You're undoing the good work you did earlier, right? Okay. All right. So you just you loop through that as many times as needed until you have got rid of all the unit rules in your big R, in your set of substitution rules. Okay? Right, now finally, so it's step 4. The rules that remain now, so they will not be. There's a sort of logic to it. Step 1, we added a start variable to the new grammar. Step 2, we got rid of the epsilon rules, where the right hand side was the empty string. And then step 3, we got rid of the unit rules, where on the right hand side was a single variable. Now we don't do anything if there are like 2 variables on the right hand side, because that's normal form. Okay, so we don't touch those. And then anything 3 or more variables on the right hand side, then we do step 4 with those. Okay, so there's a certain logic to it, sort of systematic logic to it. Handle the empty string cases, handle the 1 variable cases, don't do anything with the 2 variable cases, and now do this, step 4, with the 3 and above variable cases. Okay, so systematic. Okay, now, so in general, let's say you've got k variable, wait a minute, k symbols on the right hand side. So u1, u2, ... uk. And these are symbols, meaning they could be either a variable or a terminal. Okay? So we've got k of them. Now, to convert these, now you would eliminate that. We're just throwing out, that was the basic structure from the beginning. We throw out all those rules that are not in CNF, they're not in standard form. Okay? So we throw this out, but to repair the damage, we have to replace it with something. So what you do is, in this case, with k symbols here, right? And a symbol can be either a terminal or a variable. So what you do is, you create a new variable, and here. We create a new variable called A1, and so and the new rule that we add to the R, our growing converted grammar. So we add A1 to that big V. We add a new variable, and we also add a rewrite rule, a substitution rule of this form. So A arrow U1 A1. Now this U1 is the first, whatever that is here. Okay. Now that U1, if you think about it, it can either be a terminal or a variable. If it's a variable, then it's in standard form. Okay. If it's a terminal, then we can rewrite the A1 later. You'll see it here. Okay. Perhaps I should come back to that point later. If this is a terminal, what you do. Now A1 you can rewrite as U2 A2. So U2 is whatever, this, it's from here, and A2 is a new variable that gets added to your list, and so on. And then A2, well, that's just U3 A3 ... and so you've got A to k minus 1. Remember, you've got k of these symbols in your right hand string of the remaining rules, let's say. So A k minus 2 gets rewritten as U k minus 1, and that's the second last one. It would be here, the second last one. Okay, UK. Alright, so all these AIs, like AI K-2, A3, A2, A1, they're